Yeah, we have a really cool subject here. We're going to talk about how energy storage works, common misconceptions about it, types of energy storage, the environmental benefits, incentives, and a ton more helpful things to know about this technology. It really is very, very cool and fast moving. So I do want to start off by pointing out a lot of the misconceptions around this technology. And we kind of boiled it down as a company to the top three that we get quite often in terms of questions we get from customers or potential customers. A lot of just discussions around solar in general in the industry and how battery storage works. So the first misconception that is so common is that, as long as the sun is shining, I'll have power. Well, not quite. Your grid-tied solar system is designed to actually shut down when the grid goes down. And that's actually, in a way, a law because it's about safety. So it's a very good reason. What happens typically when there's an outage, especially caused by like an obstruction or something like that, a lineman will come out to work on it, to repair it, right? And if solar energy, that's producing electricity is feeding back into the grid while the wires are being repaired on, it could cause serious injury or even death for that lineman. And that's a risk that in this world we cannot take ever. So there's a really good reason why that power cannot be accessible when things are down in that way. So that's a really common one. We can definitely address that in our question segment a little bit more in depth, but that's definitely a notable one. So the second one there is, there's a transfer switch for, optional off-grid usage that I can flip anytime. So this is most certainly not the case. Most inverters are grid connected. That's just the most common type of installation that has to do with, solar inverters and batteries. And so with that, the inverter senses like grid differences with frequencies and voltages, and it tells it to power up or shut down. The problem with that, though, is that the system can't throttle how much power is coming in. And so if the system doesn't have that type of insight, it can't actually regulate what it can handle. So that can really lead to a very dangerous outcome. It can also be really damaging to the system. And that's another thing we can address more in depth in our discussion. But yeah, that's definitely a very, very common misconception that we have. And we get from a lot of folks, and I'm just admitting a few more folks here. And then, so our third most common misconception is I can run a generator and my solar system at the same time. And the reason behind that is that it could completely fry the generator because, again, there's that regulation issue. So that's another really huge misconception and something to note, especially in terms of safety and when you are investigating generators and things like that.
Awesome. Thanks, Jane. So this is a great visual that you guys are all looking at. And I guess we can start from the very top. Let's start from the sun. So the sun hits the solar panels. Those solar panels are generating DC power. That power then goes into an inverter. If we're following that yellow dotted line, the electricity is going into the inverter, and then that inverter creates AC power that can be used at the house. So immediately, once the solar panels generate the electricity and that electricity gets converted to AC power, that electricity wants to immediately service any of your home's electric needs. So your refrigerator's on, any lights that are on, it wants to service your home's electric needs right away. Now, if there's excess electricity being generated, typically without a battery, that excess electricity would actually go back out to the grid, and you would be selling the power to the grid.
Thanks, Eric. And Paul, can you explain a little bit how the battery comes into play here?
Why the battery matters is it kind of becomes that central hub or brains of the operation, if you will, for your solar system and the grid. What it's going to do is sit in the middle and really make decisions about where your power needs to go. So if the grid goes down, it has its own transfer switch. It'll um, flip over so that it can power your solar system based off of that battery, and then not allow any energy to flow back out to the grid. If the grid is up, it'll let the energy just pass right through and go out so you can net meter like normal. The battery will also regulate when your solar system is on and off. Again, like Jane said, if we were to just have the solar system feeding power unendingly into your house, if you didn't have the loads to match, it could create issues for various equipment within your house. And so by having that battery there, what it's going to do is it's going to almost act like the grid would, and it'll frequency shift. So it can actually change the frequency settings that it's producing to turn off the solar array without affecting any of the loads to your house. And then when the grid comes back up, that battery will pop over, change that transfer switch, and go back to its stationary mode and just letting you operate as a normal grid connected house.
Thank you, Paul. I appreciate that. So there are, with all of that in mind, there are a few different options to have assurance of power. So there are different options here laid out, and these are obviously some of the more popular ones. So battery backup. From an economic and environmental standpoint, it does make a ton of sense to tie your solar array to the grid. This allows for the usage of very cheap or sometimes free access to energy at night, and allows other electrical customers to make use of the excess clean energy during the day. Um, and so if you think about it, that's actually a very efficient system. Then we kind of shift on over to self-consumption mode. This occurs when the loads drawn from the house are present at the same time the solar energy is being produced. This energy is not stored for later use. If there is more power needed for loads more than what the solar can contribute, the excess will be drawn from the utility itself. So again, another nicely balanced mechanism to have on hand, especially when and actually when you need that. So, and kind of following that balance, the time of use mode is a mode that purposely does not draw power during energy peaks, which is a way more, it's way more sustainable for the grid and the environment, as well as economically viable. In general, a good rule of thumb is to understand that the most dirty energy you can purchase is during peak load on the grid. And it's also the most expensive energy that you will be purchasing. So time of use gives you that flexibility. And so all of these functions play into a healthy load distribution, and depending on what your needs are, one of these functions may work better than the other. And I'm going to shift it on back over to Paul for incentives.
So there's a few main incentives for batteries. So the first is very similar to the federal solar tax credit for all of you who have gone solar. So right now it's a 26% federal tax credit off the total of the system. That is for battery systems charged by solar. The IRS has specifically said for it to qualify right now, it has to be powered by solar to be considered under that federal investment tax credit for solar. As we would install for people if they did not have solar, unfortunately, they would not be able to take advantage of that. However, most of our systems are solar connected. So for a lot of homeowners who have it, that's a really easy thing to come. Like the solar tax credits too, Some people may not be able to take that tax credit all in 1 year. So you have actually up to 5 years to take that tax credit. So you can claim it over multiple years if need be to help make that battery more affordable. The other big program out there for GMP customers is they just launched a new Bring Your Own Device program, and several other Vermont utilities are looking at launching something similar, hopefully in the coming year. What this does is it actually plays off that idea about the peak loads, as Jane was discussing. So those loads, again, are the dirtiest fuels that we see. A peaker plant is basically a glorified rocket engine that creates electricity. So it's also some of the most expensive energy. Again, a base load could be 4 cents per kilowatt hour, but they could be paying north of 50 cents a kilowatt hour for those peak loads. So what GMP did was they wanted to incentivize people to have batteries where they can somewhat play retail arbitrage with your battery. So what they do is they would give you $850 per kilowatt over 3 hours, or per 3 kilowatt hours, for them to have access to your battery to charge and discharge it during their peak events. So what they say is it would be about 6 to 8 times per month that they would do this charge and discharge. And what that allows them to do is to have your battery charged up when the energy is cheap or through your solar system. But when they hit those peak loads, they can discharge the amount of power you give them access to help save some money for the utility and save, again, on that carbon footprint, because that's the dirtiest fuels. For those people who don't want to have them having access to the battery, they also do a one-time $850 incentive total for any battery to put it into self-consumption mode. And so again, that's where you could have that battery charging and discharging to power your house's loads as needed. So again, it offers them a little benefit to help shave their peaks and reduce the amount of strain on the grid. I do know that, again, several other utilities are working on this, because these distributed battery resources not only help avoid those peaks, but they're going to really, in the future, as we get more and more on the grid, help to reduce the need for infrastructure upgrades, because people will be able to do these things like self-consumption and time of use to really help, again, reduce that strain on the grid. So it's a cool new incentive for you GMP customers, and something great to look forward to for all of us who are outside of GMP's territory.
Thanks, Paul. And so regarding that carbon footprint that Paul had just mentioned, so there are obviously so many benefits, environmental benefits, that come with solar installations and running your actual home system off of solar. And that's a huge reason that more and more Vermonters are switching to this renewable energy. It is environmentally sustainable. It is an environmentally sustainable climate solution, which is a priority that I would say most of us really hold closely to our everyday practices. And in Vermont specifically, our goal is to meet that goal of 90% dependence on renewable energy by the year 2050. I think that at the rate that we're going, especially if solar just keeps the momentum that it's really shown that it has, we can really meet those goals, and I do sincerely hope so. So with that though, I mean, when you do install a solar system, you are keeping energy as local as your own roof or yard, which is an amazing feat. I think that that's in the way you get to really kind of embrace the fact that you have this resiliency and this independence energy wise within your own structure and your own property. And I think that just is a really great direction to go in, especially when that comes to alleviating, like we said, the peak load on the power grid. When you're actually producing your own energy, it really has this long-lasting difference that it makes. It has a lot of tendrils out into the entire grid system of positive reinforcement effects of installing your own system. So You know, and also in, you know, and this is kind of obvious, but when it, you know, when we do reduce our dependence on non-renewable and limited resources out there, um, it does promote those ecological benefits and that reliability that renewables really do bring to the table. So those incentives that Paul was talking about really help make this transition a reality. Oh, sorry, Paul. The Tesla Powerwall.
Yeah.
Yeah.
So we offer two main battery systems. So the first is the Tesla Powerwall, which I'm sure is many of you have heard of. It's the most popular home battery system out there in the US right now. So the Tesla Powerwall is a 13.5 kilowatt hour battery with 5 kilowatts of continuous power output. We have chosen to use the Powerwall because of its quality design and simplicity. We have in the past used several other battery companies, and what attracted us to Tesla is its simple functionality. It's Tesla makes and controls everything in the system, so they have a really good cohesion across the battery. Um, you have a standardized app that you can use, so you can really see what is uh, happening between your solar and your battery. So as that grid is down, you can easily monitor what's going on. The other nice thing is these are easily stackable. So a Tesla Powerwall is 13.5 kilowatt hours, but we can add 1, 2, 3, 4, you know, many more Powerwalls depending on your need. So, you know, someone who's just looking for some lights, a well pump, and their refrigerator, we might just do one Powerwall. But if you have an electric hot water heater or other large loads in your house, we quickly add that two Powerwalls to get you more continuous power and, of course, more storage capacity. The other main brand is Nphase. So if you've worked with us and gone solar with us, you've probably heard about Nphase in the microinverters that we use. Nphase also has been making batteries for a number of years. Originally, they were doing it just as a time of use battery to help with peak shaving in Australia, as well as states like California. This year, they launched their new Ensemble system. The reason we like Ensemble is one, it mates up well with the microinverters we use. They are going to have a linear power function. So instead of it having your solar be on or off, it will actually be able to throttle the loads for the first time. So instead of having to, you know, let your battery discharge when the grid is down to a certain level and then power up your solar system to bring you back to 100%, it'll actually be able to throttle that solar system just enough to keep any of your house loads powered and not be cycling that battery over and over, which in the long run should save some of its capacity. The other nice thing is it is very modular. We can do anything from a 3.3 kilowatt hour battery all the way up to 40 kilowatt hours. So we can really fine tune it based off of what our customers' needs.
Thank you, Paul. So kind of off of that, it does have to do with what your needs are. So you know, every household or facility is going to have different needs that need to be met. You know, we all have different sized families or groups of roommates living together or what have you. You know, your mother-in-law moves in, just unplanned things. And there are different load needs that are going to come with you know what you have as priorities as a household. So that will dictate the number of batteries you need. So you might need 2 Powerwalls, you might need 5, but you know, it really does depend on whether, you know, you're fine just having certain appliances working during an outage or you need everything running for whatever reason. So we would sit down with you and talk to you about what you absolutely would need to kind of function, you know, during an outage or or if you needed full function for X, Y, and Z. That is those are the conversations we want to have in terms of you having that total reliance and resilience on these types of systems. This is an amazing technology, and it can be used in such a versatile way. And I think that the more we understand batteries and the more efficient they become, and you know, the lighter they become, the more they can be used for a lot of these larger purposes. So we're seeing that transition happen, and more so in, you know, in recent years, but also projected out through 2025. We're going to see a 25% increase of folks pairing their solar systems with energy storage systems, which is an amazing rate of installation for that. And it's definitely something that I personally think that getting ahead of the curve on is a really good move, and it is just a true promotion of efficiency and having that independence. So with that, we are more than happy to answer any questions you have. And I just want to bring attention over to this real quick, where if you go to the bottom of your screen on Zoom, a little tab will pop up. You click on participants and then slide on over to that box that'll pop up on the right. And you can click on the raise hand thing, and I can address your question, or I'm sorry, I can unmute you, or you can unmute yourself. You can ask your question and we'll be happy to answer that, or you can just shove it in the chat. We can do that too. While I finagle that, I was thinking of a pretty common question, Paul, of, you know, if people are able to store their Tesla Powerwall outside, or their battery outside, and kind of the reasoning behind why or why not you know, of doing that. And I didn't know if you wanted to speak to that a little bit, Paul.
Sure. So here in the Northeast, unfortunately, batteries need to be in a heated space. You will see in some promotional photos from various companies them outside, but the problem is the cold weather. The Tesla Powerwall needs to maintain at least 32 degrees before it starts derating its performance in terms of its power output as well as its overall stored capacity. Kind of similar idea to your car battery, you know. We get those really cold winter days and your car just doesn't want to work as well. So the battery has that same function. So where we want to put it is a heated garage, a temperature controlled basement, places like that, so that we can maximize the quality and effectiveness of your battery. If we were to put it outside, you know, all summer long, it would be great. But in winter, where you really want to make sure it's working, it just might not work, because obviously here in Vermont, it gets much colder than 32 degrees.
Absolutely. That's a good point. I feel like we do get that question quite often. I think I had one more and it just kind of slipped. It'll come back to me. But Paul, do you any other really common battery questions we get? I feel like there's just so many.
Yeah, I mean, I think, you know, a lot of the batteries, similar to solar, comes down to what you need at your house. You know, we look at what your loads are, what your intended usage is, how prevalent any one of those loads are. And so, you know, some of the best things to answer questions is to, you know, have us out for a free site evaluation where we can talk you through your specific needs. Because more than a solar array where we're just looking at your overall kilowatt hours usage for a year, we're really looking at what are your incidentals if the grid were to go down. You know, do you have an electric hot water heater, or is it gas can make a big effect? If you have an electric hot water heater, is it just you and one other person living in the house, or do you have a bunch of teenagers who are going to still want to shower multiple times a day? Those key things matter, because when you have a finite storage capacity, potentially, we want to make sure we're meeting or beating your needs.
All right, thanks for that. And then, so we have a question, a hand up here from Maggie G. So I'm going to ask you to unmute and you can ask your question.
Hi, thanks Jane and thanks Paul. Maggie Gordon from Heinsberg, and I have a bunch of questions, so if you see any other hands up, feel free to cut me off and I'll come back later. Interested in, are you seeing prices come down, and is it worth holding out if you're seeing a steady decrease in price? Is it worth waiting?
The holding out, I think it's somewhat of a question, kind of like when do you invest in a new computer or a new phone or things like that. The technology will be getting better. I think it really comes down to a personal level of when you, I guess, or how much you need that battery to protect your house. I mean, if you have a generator right now that's working and keeping your house going, maybe it's worth the wait. But if you don't have anything to back up your loads right now, and you're worried about longer grid outages and losing the food in your freezer, or just that insecurity of not being able to work from home in today's modern environment, then it's definitely a good time to invest. I don't see battery prices falling through the floor in the next few years. I think it's going to be similar to how many products work and solar has worked over the last few years, where we're just going to see slow incremental decreases.
Thank you. So I understand that it's difficult to get a sense of, because this would be my primary use is the longer power outages.
Mm-hmm.
And trying to get some kind of a sense of really it's the I can go a few days without power, but it's the long stretches, it's the over 5 days, which is really difficult, and those happen every few years. And if I'm just talking about fridge, very low use of lights and well pump, how long can I expect? Are we talking 10 hours, 10 days? Do you have any sense at all with
Sure. So since I did your solar system and know roughly your house, my guesstimate off the cuff of our previous conversations and your old electric bills would probably be a day with no additional input. One benefit though is that you would have your solar system attached to that. And so as long as we were getting a reasonable amount of light into the system, you could easily produce enough power to recharge that battery and keep you going. But that would be, again, the bare minimum loads of just well pumps and lights, maybe your internet router and your fridge.
Yeah. So that's doesn't even include the heat pump.
Heat pumps and batteries are not a good combo. And that's actually one of the myths maybe we should have addressed earlier. The thing is, heat pumps are not a high draw load, but they actually, over the course of a day, can actually really draw some power.
Okay.
So like my heat pump in my house, especially on a winter day, can draw 30 kilowatt hours by itself. So, what that would do, I mean, that could drain that battery 2 times over by itself. So we don't recommend batteries to run your heat pumps. We would want to look for, an auxiliary system. So, when the grid goes down, my heat pump goes off and I switch to my wood stove.
A question from Hannah R. So in terms of, it's Nphase, as we know, comes with that 25-year warranty. So Hannah was wondering if Tesla offers a similar warranty, and was also curious about the expected lifespan of those batteries.
Sure. So actually, both batteries come with a 10-year warranty in this instance. So Nphase comes with a 10-year warranty or 3,500 cycles, I believe, is what they say. So that would be, a cycle is every time you use 100% of your capacity. So that could be, if we're going to use 10 kilowatt hours, going from 0 to 10 and back, or going 10 to 5 twice. Tesla comes with a 10-year guarantee, unlimited cycles, but they only guarantee 70% of the capacity by the end of the 10 years. But that, if you do the math out, that's a lot of usage. I mean, that's 365 days in a year times 10 years. That could be 3,650 cycles reasonably. So very similar warranties in terms of the batteries. We're not really seeing any battery company go much beyond 10 years. There's one battery company that has, I believe it's a 12-year warranty. But I think, with the newness of the technology, we are not going to see warranties creep up for a while. And that's something similar to what we saw in solar, is that when technologies were new, a lot of panels or inverter companies only had 10 years. And then as they got more and more comfortable with their product down the road, they were able to extend those warranties out.
Wonderful. Thank you, Paul. And then I'm just going to hop right back to Maggie if you want to unmute yourself and ask your other questions.
Is there a meter on the battery system to indicate how much power is remaining?
Yes. So both battery systems come with an app. So you would not have a physical meter on the system to show you what it is, but you could log in through your phone and or computer or whatever device you wanted to use and see what exactly you have. And you can even do that remotely. So you don't have to be in the presence of the battery. If you were out of town, you would know that, hey, I have X amount in my battery.
Okay. Good reason to keep that Wi-Fi on when the power's out. Do you have a loan partnership set up the way you did for the solar systems?
Yes, we do. We work with VSCCU as well.
Okay.
And so they will do the similar solar ITC loan with that. And so we can do a 7-year or a 12-year loan on that. And similar to the solar system, what they do is they'll finance that full amount up front with a lower loan payment, under the understanding that you're going to be paying back the solar ITC when you recollect that from the government on your next tax return. Then you put that in, you keep the same loan payment. But again, like last time, if you decide that, hey, you're not going to get a 399 loan on something else and you want to take that money and invest it elsewhere, there's no penalty to that. They just have you re-amortize your loan to keep the same 7 or 12-year payoff.
Thank you so much, everyone. This was so nice, and I appreciate the involvement and all of the really great questions. So take care, stay safe, and I'm going to go ahead and end this meeting.